Hi everyone. We're going to start this section with a little warm-up to remind us about the distributive property, which is hopefully pretty easy, but I want you to really think about where you started and where you ended up when we do this. Our big goal is to work on factoring and solving factorable equations, but factoring is really reducing the distributive property. So if we kind of look and think carefully about this, we might see a little bit of where we're going. The distributive property really just says if you are multiplying and one of your factors has addition or subtraction in it, you can perform the multiplication by just making sure that the other factor gets applied to each term, each thing that's separated by a plus or minus. So here we would have to multiply the 2x by the x cubed, which would give us 2x to the fourth. We would have to multiply the 2x by the 4x squared, which would give us an 8x cubed, and that subtraction sign in the middle just stays there. And then we would multiply the 2x by the 7, we would keep the plus in the middle, and we would add on 14x. So one of the things we will be working on is starting with something like our answer and trying to work backwards to where we started. So we'd look at each term and say, is there something that we can divide out of each term and write out in front? So factoring is like a division that's happening. The next one is a little bit more standard for what we're going to work on. We're trying to multiply a binomial with two terms, that's what binomial means, by another binomial. So both of the factors have an addition or subtraction in them. So there is a shortcut for this. It's not that short, but if you like it, it just kind of helps you organize yourself. It's FOIL, which just reminds you that you have to multiply the first two together. You have to multiply the outside two together. You have to multiply the inside two together, and you have to multiply the last two together. And if you do that and add up all the things that you get, you should have the correct answer. Really, what you have to do to multiply this without using a shortcut like that is just pick one of the two, I'm going to choose this one, and distribute it into the other set of parentheses. So just like above, except the thing we're distributing through has a subtraction in it. I'm going to write out an intermediate step here. The 5x will have to get multiplied by the 2x squared minus x, and the 4 will have to get multiplied by the 2x squared minus x, and that plus in the middle is the same plus that was in the middle before. This is not fully multiplied out yet. I multiplied the first factor through, but I can still do better. I can now distribute through each part of the second factor. So if I multiply the 5x by the 2x squared, I get a 10x cubed. 5x times x is 5x squared, keeping that subtraction in the middle. 4 times 2x squared is 8x squared, again keeping the addition. 4 times x is just 4x, and I'll keep that subtraction in the middle. The last thing you do when there's something messy like this is just check for like terms, and we did get like terms. We got a negative 5x squared and an 8x squared, and because everything about those two is identical except the coefficient, the variable is the same, the power is the same, we can just count up how many x squareds we have. If we have 8x squareds and we need to subtract 5 of them, we will end up with 3. So our final answer is 10x cubed plus 3x squared minus 4x. And maybe you can start to see how it would be a lot trickier to look at that answer and work our way back up to what we started with. But we're going to want to do that. That's going to be one of our big goals. I don't think I have you factoring anything that ends up looking quite this messy unless it's already partway done for you. But just to show, we can use the same idea. There's no FOIL shortcut for this one, but we can use the same idea of distribution if you have more than two terms. So we would get 3x squared multiplied by 2 minus x cubed, 4x multiplied by 2 minus x cubed, and 1 multiplied by 2 minus x cubed. You don't really have to write the 1 times there, but just to show what we're doing here. And now I have to do a second set of distributing, which again is very boring with the 1. And I end up with a 6x squared minus 3x to the 5th, exponent rule showing up again, plus 8x minus 4x to the 4th, plus 2 minus x cubed. And again, when they're messy like this, check and see if you can combine any like terms. I am seeing an x to the 5th term, an x to the 4th term, an x cubed, an x squared, a plain old x, and a constant. Not one of those has the same variable with the same power. So this is actually it. I'm done with that one. Okay, so again, think about looking at that final answer and trying to work your way back to what we started with.